That would have been the 95% rule too, because it was 2 deviations.
Yes, it was 2 deviations away.
Yeah.
Because the standard deviation was 2, and so it was 4 inches on each side of the mean.
Right.
Right?
And yeah, and see, I got that, like when I was doing it, I got that -2 and +2, and I was just looking at it. I think I overthink where I think, well, what are they asking for? Like, and then I keep thinking it's like you've got to plug in something else, and I just, I get to that point and I don't just leave it there. It's like I always like double think myself. And then the last one I missed, and I don't know why. I put 160.2.
What does it say?
Find the 35th percentile of the LSAT scores. Give your answer accurate to 1
percentile. So then the 35th percentile, so you would put the 0.35 up at the top of the applet, and then you would click only the right side, the left side of that applet. Only the left one would be, it says find the 35th percentile. No.
Find the 35th percentile of the LSAT scores. Give your answer accurate to 1 decimal place.
35%. Let's see where I was doing that. I can find the 35%. What were the LSAT scores? What was it?
Yeah. Hold on.
The mu or whatever.
Well, no, I don't know what happened. Okay, I was just on it, and then it went away. Okay.
1 of 35.
Okay, I put, okay, let's see. 150.7 is the mean. And
150.7. Okay.
Yeah. And then,
okay, so I found the z-score.
Yeah, that's what I did.
157 minus 150.7 divided by 10.6. I got a 0.618. And then the next one was, so it was a negative. I think you were solving for x. They gave you the z-score of minus 0.3.85, right? And so then you do your thing. You divide it by or times it by the 10.8 and then subtract the 150.7, and then I got like 140. I got a 70.732. I plugged that in the applet and clicked only the left side, I think, and I got a 0.268. Is that it? Let me see. Let me go to my applet and see if that is right. Oh, wait. Okay. So if I got a 0.732 up there. It gave me the z-score of a negative. Okay, let me try that. 0.385. I don't know. I don't remember what I did.
What was your answer? What's your answer for it so I can just...
I think I got a 0.268 is what I have circled. So
for number 10 on the quiz?
Well, I don't. Okay, I'll have to, let me go back and look.
Because I don't know. I did that formula and I don't know. I just really don't see why.
Okay, maybe if you have the answer, because yeah, I did get that one right, but I'm just not sure how to. Okay, details.
Did you get 160.2 for your answer?
Oh, Okay, find the 35th percentile that LSAT scores. Okay, I got 146.8.
Okay. Okay.
So what did I use that? Oh, that 0.268 was for number 8.
Yeah, that's what I got. I got number 8 right.
Okay.
I didn't get
Okay.
number 10 right. My answer I put 160.2 and I don't know where, or I guess I just miscalculated something.
It might be because that looks like you're solving for X,
Mm-hmm.
and so yeah, that's 146.8.
Okay. I probably just made a mathematical error somewhere. Because I was like, what in the world? Like, I don't know.
And see,
Anyway.
I got all those math ones right, and then I get the stupid 95 rule wrong.
Yeah, which I did too. I missed both of those same ones because it's like they're so simple, but the answer's, just basic, but you're thinking, okay, what do I got? I don't know. I overthink it. I think, okay, what formula am I supposed to, I don't know. And, and then all it is asking is what is this 68, 95, or 97?
Right.
So, anyways, whatever. Is Kelsey, are you there? Oh, there she is.
Yeah, I'm back. I just
Okay.
don't have my camera working.
You're what?
Yeah.
You're.
My camera's turned off for now. I had to go and find the app on my phone so that way if something happens, I can at least keep going.
Okay. Okay.
Okay, so should we get this done? It didn't seem like it was too bad.
Right. It was pretty good.
Homework.
Yeah. It's pretty much just explaining the central limit theorem and the sampling distribution stuff. So.
Okay.
Do y'all want to start with the part 2?
Okay. I thought that was pretty interesting. I used that random.org.
Yeah, me too.
It does something with the air. Anyway, thought that was pretty strange. Okay,
yeah.
Whatever.
I know. So are we each just supposed to do that and get the 5 numbers? Because I just went ahead and did it. Did you do it?
Yeah, I did it. I did it 3 times to see what I got a few different times.
Yeah, I did it, and but yeah, I mean, it kind of lets you know. But for number C, 7C, does your sample mean appear to be unusual? Explain why you think it is or is not unusual. I put yes, it's unusual because the sample size is small and it would be right skewed. Is that what you guys thought?
No.
Oh, okay.
What do you think? What do you think, Kelsey? You gotta break the tie.
Are you there, Kelsey? Oh.
Oh. Anyway, I was edging.
Oh.
Yeah.
I can't hear you. Are you there?
I should be.
Okay. What is your what was your thoughts on C? Are you there? Hello?
Here. Let's see. See if I can get this to work.
So why did you not think it was, Linda?
Well, because it's normally distributed.
Mm-hmm.
You see, you can see it's normally distributed, and anytime it's normally distributed, the sample's not going to be unusual. And it did say in our reading that if the sample size was 30, even if it was moderately, let me read this to you. I wrote it down.
Okay.
If moderately skewed distribution sample size is 30, it's usually enough to normalize it. So there's 2 reasons why. So there is 30 sample. Well, wait a second. Our sample is only 5.
That's why I put it as small.
But if it's, okay, so when the sample size, okay, then I'll read you the first one. If parent population is not normal, okay, when is X normal? If the parent population is normal, normally distributed, which it is, then the mean is normal no matter any size of the sample. Okay, if the parent population is not normal, then the sampling distribution will be approximately normal if it's a larger size sample. And then later on it says 30 is usually enough for a larger size sample. So, and if parent population is almost normal, nearly symmetrical, then a sample size of 5 will probably be enough for a normal distribution.
Oh.
So this one, that's how I put yes. I mean, I put no, that it wasn't unusual.
Okay.
Anyway, that's
okay. Yeah.
Because it's even if it was a little bit skewed, which I don't see that it. I don't know. It's hard.
Right.
That's hard for me to tell. But anyway, it seems like even 5 would be enough.
Right.
To
Okay. I just like when I put mine on the little thing, like my numbers, my 5 numbers when I plotted them and did the little bell curve, it just seemed to go to the right a little for some reason. I don't know why. I don't know. And then I just look at it being. But you know what? I think you're right because I think it has.
The first time I did it, I got 44,120, which is halfway on the left side. And then I did it again with random numbers, and I got the exact same position, but on the right side. And then I did it a third time, and I got kind of close to the second one. Anyway.
So I guess. Okay, so I guess the rule is, so like this graph that we're looking at, it's normally distributed. So any sample you do within that is going to be normally distributed, right? That's the rule. Okay.
Yeah, so, even if it's just 2. Did they say more than 1?
Right.
It's something about 1.
But if it was to be right, if we were looking at a right skewed distribution right now, and it was a very, very small sample, then it would most likely be unusual because, but if it was a right skewed distribution and it was a large sample, it could be usual.
Yeah, that's where it's a little confusing.
Right.
It's just, you have to decide whether it's a lot skewed or not a lot skewed. Because it said for moderately skewed distributions, a sample size of 30 is enough. Which kind of surprised me because I thought, well, at least they want 100 or something, but.
Right.
Because they kept giving this sample about these 45 women, and it's like, to me, that wasn't a very large sample. In my mind, I was thinking it wasn't a very large sample, but they're saying it was enough. In the scenario they were giving, they said that's a large sample size. Oh, okay.
Right.
Okay, if you say so.
Right. Okay. So I think I understand. I think it's just mainly the ones that aren't normal are more likely, if it's a small sample, to be not distributed normally. But the ones that are a normal distribution, it doesn't change shape. Wait. No, yeah, it says the shape, regardless of the sample size, the shape of the distribution mean is normal. So regardless of the sample size, the shape of the distribution of the sample mean is normal.
Yeah, so even if we could pick up 2 and divide it up, and it would be there.
It'd still be normal.
Right.
Yep. Okay, I get it now. I think I was thinking backwards on that one again. Okay, compare your mean from question 7A to the means obtained by at least 3 Okay, other individuals.
So yeah, what did you get for your mean?
My mean was 45,000.
45. My
Mm-hmm.
first one was 44.20.
So
So
pretty close.
that's close. Yeah.
Yeah. Huh.
My second one was 48. So
Yeah. But aren't they, didn't it say somewhere that the mean is always the same? And for the rule, isn't it? The mean is, I mean,
the
yeah,
mean the mean is the mean of the sample mean
is always
is the mean.
same as the
Yeah.
distribution mean or whatever.
Yeah.
The
So
distribution. Okay.
that's always the same. So I don't know. Why did they have to call it something different? I don't
I don't know.
know.
Oh my goodness. Okay. Well, the next one, number 8, I just did what is the shape of the distribution of the sample mean for all such sample. What is the shape of the distribution of the sample means for all such samples?
It says in the question, the scores of the GMAT are normally distributed.
Right.
So it tells you right there, even without
Right.
looking at the plot, that it's
Right.
normally distributed.
Right. And then for the next one, I did, how do you know the distribution of the sample mean has this shape? Because
It says so?
yeah, it says so. It's like kind of like
Because it says it's normally distributed?
yeah, that's all.
I don't know. Maybe
Yeah,
that's what made it easier. It's like, okay, give me all the
Right.
answers. And then the mean, the next one, with the mean, it gave you that. That's 529. That's 529. Okay.
Yep, and then
Okay.
the
So we actually had to calculate the last one.
I got 3.16. Is that
I
what?
got, well, no.
No?
If I take 113, I'm just learning how to do this. It's been so many years. Okay, so 113 on my calculator.
Oh, you know what?
Divided by 10 square root equals 35.733.
Yeah.
Or 337. So 34.
Okay. Yeah, I just forgot to do one. Yeah. Okay. Yeah, I got that too. Okay. Okay.
They give you information that you don't need. I guess you don't need the mean in that one. So
Right.
So that's going to be the hard part of the exam, is figuring out what formula to use, whether you use the other one or what are you solving.
Right.
Anyway. So,
Yeah.
but oh well. We'll
Mhm.
plod through it, see what happens.
Yeah. Exactly. Okay. Is Kelsey gone again? I haven't.
I think she's back.
Okay.
Are you there, Kelsey? We just can't hear you because you're making a lot of noise.
Okay.
Yeah.
Can you hear us okay? You sound like you're
I
at
mean,
the
the
other
last
end of
time I
the...
got out the tunnel, I feel like it. Oh, who did we lose? This is crazy.
Okay. Well, we can hear a little bit of what you're saying. Should we get started on our thing? Let's see. What does it say? On our group. The group meeting quiz. Okay, ready? Are we still ready to start?
We lost Sari.
Oh, we lost Sari.
Oh, there she is.
Oh, she's there.
I'm here. I don't know what happened.
Okay. Are we ready to start? Let's
Yes.
start. Okay. Let's get going.
Yeah.
Okay. When taking samples of n, when n equals 5, what was the shape of the distribution of means histogram when the parent population is right skewed? Okay, that's that little thing, that sampling distribution. That's something I didn't really get that well. Okay, so I put it skewed.
We're starting the quiz. Did you just start the quiz?
Yeah.
Okay. All right, hold on.
When taking samples of n, when n equals 5.
I'm taking samples of n equals 5. What was the shape of the distribution of means?
When it's 5. Distribution of mean when it's 5. Okay, let's see. When n equals...
Okay, when n equals 5. What was the shape of the distribution of means?
When n equals 5.
Histogram.
For me, it looks like it's right skewed.
When the parent population is right skewed. Where is there something that you can look at that? Are you
didn't see that in the reading?
No.
Okay. If you go to, it's that first thing. Let's see. Okay. It says it's under step 5, Introduction to Sampling Distributions. Go to the following link. It says onlinestatbook.com stat sampling.
Yeah, I didn't see that. Okay.
That's the thing. And then if you watch the video, the guy is using that. The teacher is using that.
Oh, yeah, I watched the video, but somehow, okay, so, okay, I know what you're talking about. I just kind of wasn't, I know what you're talking about. I just haven't actually gone to that site yet and looked at that. Okay, so let me see if I can find it. Book. So you're on that little website right now?
Yeah, I just left it up. I've got the probability applet up, and I've got that one up.
Okay.
Just in case I had some questions.
All right, so I'm on the website. So what do you do after you get on here to find the?
Well, it said, so the first box you put skewed, because that's what the question is saying. And then the distribution of means, which is the third one, you put n5, n equals 5.
Wait a minute. Okay, I just clicked on it says click the begin. Oh, begin. Okay.
Yeah.
Okay, and
That
then
button.
okay, and then 5. You hit 5 on the mean.
Third one, it says distribution of mean. I'm not sure how this is just what I did. N equals 5. And then I clicked 5 up there. Let's see. Click animate it. So
Oh, wait. Okay. All I see is like the top little graphy thing is black. Then underneath it says like animated 5, 10,000, 100,000.
okay. So if you go down to the third one, it says, and see on the very top where it says parent population.
Mhm.
And and then did you look at where it says clear lower 3?
Yeah.
And then right below that it says normal.
Yes.
Okay, click on that little button next to normal. And put skewed.
And then it goes to the right?
Yes.
Okay. Okay. Yeah.
Okay. And then what else did it say? It said, okay, it said to make it skewed. What was the shape of the distribution of means histogram when the parent population is skewed right? when n equals 5. And so then the next one down says distribution of means, n, you can have n2, n5, n10, all the way up to 25. So it's asking for n equals 5. So do that. And then I don't know about this one. I clicked 5 on the one on top, and then I hit animate. Is that right? And then I get a right skewed thing. It's only 5 little blocks, but it's right skewed.
Right. Okay. Yeah. All right, so you clicked animated, and underneath the animated, it's 5. And what about the 10,000 and 100,000? Did you leave those those numbers?
Well, let's see. I click on the 5 again. Well, this is a sample of 5, so that's why I clicked 5.
Okay. Yeah.
I
Okay.
don't, whatever. Yeah. I'm not sure.
Okay.
About that very well, but I would say skewed right.
Okay, let's just put skewed right. I think
so.
Okay, when taking samples of n equals 100, what was the shape of the distribution of mean? Histogram when the parent population is right skewed. So we got to go back to that, I guess.
Go back, and it's right skewed when it's 100. Well, it doesn't give us that option.
Right.
Okay, clear lower 3, start over again. Then it only gives us 10,000.
Yeah, that's what, can you not, I guess you can't change it.
Let me click, this is, okay, let's see, and 25, I wonder if we hit, okay, n equals 100, so if we go and 25, wonder if we can do that 4 times. Let's animate it. 1. There's 1 set of 25. Let's see, 2 sets of 25. How that just disappeared. 3 sets of 25. 4 sets of 25.
I wonder if you have to click on it 100 times. No, I mean, let's see, 5 divided by 100. What is that? I don't know. Like if you click on it 20 times, would that be a sample?
Oh, okay. I think I got it. When I did that, now the distribution of means, the third one, is normally distributed, because when you have that many, even when it's right skewed, it will end up normally distributed. How about that? Because mine has just a regular like bell-shaped curve. My distribution of means now.
Well, that's what I did. I clicked on it 20 times. Is that what you did?
No.
I just clicked on that 5 20 times, so it would be like 100.
So did you get a normal shape too?
I did.
Okay.
I did. Yeah.
Great. Okay, so we'll say normal.
Okay. All right. Kelsey, are you there? Is she here?
Well, her picture's there.
Okay. Oh, no.
We've got our home teachers coming in like 15 minutes, so we'll try to finish this up.
Okay.
When taking samples of n equals 100, what was the shape? Oh, wait a second. Oh, that's the same thing. When the parent population is normally distributed. Well, that's normal. Okay, on to the next one. When it's normal no matter what the sample size is.
Okay.
Okay. When would the distribution of means be normally distributed? Choose all the correct responses. Data are drawn from a population that is normally distributed and the sample size is small.
Yeah.
Click. Data are drawn from a population that is normally distributed and the sample size is large.
Yep.
Yes. Data are drawn from a population that is right skewed and the sample size is small.
No.
No. And data are drawn from the population when a right skewed is right skewed when the sample size is large.
Yes.
Okay. Yes. Okay. So
All right.
3, leave that one blank.
Okay.
Okay. Which is the following gives the best explanation of central limit theorem. Okay. Let me go back then.
Yeah, I wrote that down.
So
Says as the
it says,
sample size n increases and becomes large, the distribution of the sample means become approximately normal.
okay, so let's see what it says. If the parent population from which the data are drawn is normally distributed, then the sample size x will follow the normal distribution. Let's see, for bell-shaped data, approximately 60 within one standard mean. No, that's not that. Okay, I've eliminated one of them.
I think it's the last one because it says if the sample size is large, the shape of the sampling distribution of the sample mean will be approximately normal. And that's
Yes, that's it.
Mm-hmm.
Okay. Well, I didn't know if yours were in the same order as mine.
Oh yeah.
Usually it doesn't happen.
I know. Usually it doesn't.
Let x be the random variable, and 10, and the population deviation is 6. Okay, now we figure that out, I suppose. It's drawn from the population. What is the mean?
It's 10, right?
Okay.
What is the mean of the distribution of sample means? Isn't it the same?
It's 10.
Yeah, it's 10.
That's 10. Okay. What is the standard deviation of the sample mean? Okay.
We gotta do
Then
that.
we've got standard deviation. So that goes on top. The standard deviation is 6 over the square root of 36. Is that right?
Yeah.
6 divided by 36 square root.
1.
1?
Yeah, 1.
Is that right?
Yeah, that's what I got.
Okay. 3 decimal places. I don't know.
Okay. Regardless of the distribution of the population, if the sample size is large,
Over 30.
then
What would be this? You would take the distribution. Normal.
Yeah, normal.
Okay. What theorem would justify a response to question 10? Okay, regardless of the distribution of the population. So, the law of numbers says the greater amount of observation in samples, the sample mean draws closer to the population. It's large, so it's yeah. I would say it was the law of large
numbers. Yeah.
And the greater the sample size, the more confident we are in its accuracy.
So regardless of the distribution of the population, as long as the sample size is larger than 30, it's always going to be equally, like it's always going to be like a bell-shaped. Is that or not?
Well, when it's it says for moderately skewed distribution, sample size of 30 is large enough. So Maybe it's not enough for severely right skewed or severely skewed.
Okay. I don't know. What would the shape of the distribution? Okay. I was just wondering, like, what that, like, how far that rule went with that. I don't know.
Well, I can check. Let me check it. Don't click yet. Let me check, and then you
Okay.
can pick yours this time. If it's
Okay.
not.
Well, last time when we did it and you couldn't get it to go through.
I can go through. Okay, we missed one. Yes.
Oh, which one did we miss?
The last one.
Oh my gosh.
It says it's central limit theorem. So I guess 30 was large enough.
Okay, what
so
theorem justify response?
pick number 11 on yours and put the central limit theorem, and then you.
Yeah, last time on that quiz that we took together, and yours wouldn't go through, I missed one. Like, we really only missed one as a group, but I missed two because I just accidentally hit the wrong, like, C instead of B, you know? It's like, oh my gosh. Like, anyways, whatever. I'm like, some days.
Yeah.
Not paying attention. So
the central limit theorem says as the shape size increases and becomes large, the distribution of the sample size becomes approximately normal. They said in the reading those two things weren't close to being the same, but it could have fooled me.
I know, because on number 5 in the homework for the preparation assignment, it says, what is the difference between the central limit theorem and the law of large numbers? So you're supposed to find the difference in that. So
if you watch the video, he was saying it was accuracy, that the law of large numbers, the accuracy was greater. It was more accurate.
So that's the difference?
I don't know, that's what I put, but then it said something different. The central limit theorem states that if the sample size is large, the sample mean will be approximately normally distributed. That is it. The law of large numbers states that as the sample size increases, the standard deviation of the sample means will get small. Oh well, maybe we'll understand it a little bit more. I'll go over this again.
Yeah, I will.
Once I go over it a second time, it always makes more sense.
Right. Yeah, me too. I don't know. Well, hopefully Kelsey got some of this.
Kelsey, are you there?
I have no idea. Can you hear me?
Oh, yeah. We can hear you now.
All right. Did you get it?
Good.
Did you do the quiz with us?
I could I heard the first question and then the next one.
Yeah.
Oh, she's gone again.
Okay.
I was like, yeah.
Well, we just finished it. The only one that we missed was the last one, which is the central limit theorem instead of the law of large numbers. And we are kind of a little bit confused on that, the central limit law theorem and the law, what's the difference between the two? So if you figure that out over the next couple days, that would be good. So anyways, I guess we can end this now. Are you okay?
Or Kelsey, we can go over those with you.
Yeah. Do you want us to go over them with you? Are you there?
No.
What was she saying was going on? Her computer wasn't working, or?
Yeah, I'm not sure. Something.
Yeah.
Oh.
Are you there? Okay.
Yes, I'm back again.
Do you want us to go over the answers with you real quick on the quiz, or did you get it? Okay.
Well, because I don't understand the graph thing that you guys were talking about at the beginning.
Right.
I don't understand how it's But I don't know how to work it. Let's put it that way.
Okay.
I didn't see that either.
Okay. Yeah. The only.
Well, you almost don't need it if you
Yeah.
know that if it's a large number, it's going to normalize even if it's skewed right.
Mhm.
And if it's a small number, like 5, and it's skewed right.
Right.
So number 3,
Okay.
when it was only 5 and it's skewed right, then your answer will be skewed right. Okay. But in number 4, if it was 100, then it's going to stabilize and it's going to be normal.
Okay. So the normal makes sense.
Mhm.
Okay.
So the 5 I still don't quite get.
Well, because your
Like, I
parent
don't understand
population
how.
is skewed right, and so the 5 is a small number. It's a small sample, and so your answer is going to be skewed right.
Well,
Oh.
it's just like a
Okay.
the set rule on that. Like you can't.
Yeah.
Yeah. It's just set rule.
Yeah. I just wasn't reading it, and then I went to the graph and got more confused.
Yeah. Mhm. Yeah. I mean, yeah, I think that whole graph thing is just like people that are visual learners. It kind of shows them how it works, but you don't necessarily. I don't think you have to. If you know the rule. So I don't know. Kind of.
Okay.
So which number? Where are you at on the quiz?
I'm like halfway through.
Okay, so have you done number 6 yet?
That's the one I'm looking at right now.
Okay. We put all of them were right.
Sarah, can you help her? Our home teacher here, so I'll just drop out. Okay.
Yes, I will.
Okay. Bye, guys.
Bye. We'll see you Wednesday. So we put all of them. All of them were right except for data are drawn from a population that is right skewed and the sample size is small, which is the third one on mine, but I don't know if it's the third on yours.
It's the third one on mine also.
Okay.
Yeah, it is.
Okay. And then on number 7.
That makes sense.
Yeah. It's just kind of the rules that, are listed. And then number 7, we put if the sample size is large, the shape of the sampling distribution of the sample mean will be approximately normal, which that's the definition of the central limit theorem. So.
Yeah. I remember reading that, so.
Yay! I know. And then number 8, we did what is the mean of the distribution of sample means? It's always the same as the mean, and they give it to you, so the mean is 10.
Perfect.
Yeah. And then what is the standard deviation of the distribution of sample means? And how you do that is you take the standard deviation, which is 6, and you divide it by the square root of your sample size, which is 36. So the square root of 36 is 6, so 6 divided by 6 is 1.
1.
Yes.
Yay!
Yay. And then,
nice.
I know. And then regardless of the distribution of the population, if the sample size is large, which is n greater than 30, what would be the shape distribution of the distribution of sample means? And we put normal because it's a large distribution.
Yeah.
And 11 we missed, but because we put law of large numbers, but it's actually central limit theorem. What theorem would justify your response to question 10? But we don't really understand that. So that's just something I think we need to read on a little bit more, because they kind of both seem the same to us, like the law of large numbers and
we'll look at it.
Yeah.
Yeah.
I don't know. But
I can look it up in an email if I find anything.
Yeah, or when we just meet Wednesday, we can. I know Linda said she was going to read up on it a little too. So. All right. Well, I guess we can meet back on Wednesday.
Okay.
All right. Hopefully
So
everything.
hopefully we figure it out.
Yes. Okay. We'll see you Wednesday.
Today. Good. You keep hearing me. It's eventually going to turn off.